5 quiz. And do chapter 6 homework and notes.
So if it wasn't on the chapter 5 quiz, it's not gonna be tough.
From chapter 5 now. I can do it a little differently though, so watch this. Say from chapter 5, I would say, name the halogen with the second smallest electronegativity.
So that
Fluorine? Oh,
Would
second.
that be iodine?
Oh, iodine. Second, I was thinking second largest.
Everyone see that? Everyone see that? So, what did I say, electronegativity?
Yeah.
So electronegativity increases left to right, decreases going down. You knew the halogens were here. Right there's the second smallest at iodine. That makes sense?
Yeah.
So I can cover, and then also, I would put the symbol, then the name, because we have the names of those required. So I'll be able to check a lot of the names without listing. Remember in the back of the quiz, you just had a list of, what, I put 40 something on there or more, of just elements and their names. I can now check multiple things. Okay? I could also do stuff like this. Name the, I think we've done some of these before, name the, if I gave you manganese, cobalt, rhenium, and iridium, which one has the largest radius? Largest radius, because the trends are decrease, increase. Okay? Name the lanthanide series with the largest electronegativity. I'd have to take either one of those. Lutetium or ytterbium.
Wait, so why would it not be 71? Why would it be 72 maybe?
Do you want the truth or do you want the lie?
True.
the law.
The truth is, we kind of lied to you when we did the flow chart. If you remember the flow chart, after 6S2, we circled up around and went 4F, 1 through 14. Believe it or not, after 6S1 and 2, it goes 5D1, then 4F 1 through 14, then comes back and finishes the 5D. Do you understand? But it's okay, don't worry. We're not really worried about that. Look at the periodic table that you have. If you see this one, notice how they have this one actually right.
Yeah.
Look at this. After barium, 56, do you see how they have 57 is there? Then they have the entire F block. If you look at that, you know how this one's 15, this one's 15 long, this one down here is now 14 long. That's the F block there. Okay? I'm not really worried about that.
Okay.
Alright? No, I'm not worried about that. About the last time, honestly, about the last time we deal with the F block.
Okay.
We'll start bonding things together, and there won't be any of the man-made elements in the F block that we're bonding. Okay? Anything else? Any other questions? The weather stuff's not on test. If we wanna test over that afterwards, we will.
You're not gonna
Want
add,
to, right?
you're not gonna add any definitions from chapter 13 that were on this, so.
Wait,
From what?
Oh, chapter 5, I don't know.
From chapter 5?
so-
No.
Okay.
Whichever ones were on that quiz. You ready to get the quiz out and go over it?
Wait, you said
Yeah, sure.
Are you gonna put elements on it that we have to name again?
Yes, but I just said, I found a more creative way to do it too. I mean, I can check a lot of those. block element. Maybe a P block element with an anion of 2. And it's the second largest electronegativity in its column.
Sulfur.
You wanna see it? You wanna see sulfur? Please tell me you want anion 2, you guys are sharp. I want anion 2, you guys went right to 0, -1, -2, has to be one of those. And then I said, second smallest, I don't think I can trick you, do you understand? So that's what, we'll do some of that. Name me an element that's extremely happy with a duet. Name me one more. Hydrogen. Hydrogen, helium. Everyone agree? They're striving to get 2 electrons in their outer shell. Name me an element with octet. It's heavier than lead. Radon. And it's a gas. That's crazy. Remember that? Show me the formation. Let me do one that's harder than, let me do the hardest one I could do. Show me the formation of calcium and phosphorus. Bond calcium and, show me the formation of an ionic compound between calcium and phosphorus. Do they even form an ionic compound? I'm just gonna check the electronegativity. Probably don't, but it's okay. A 1.0 and a 2.1. Yeah. The 1.1. Ionic compound between calcium and phosphorus. No, 1.1 doesn't fall in there, does it? Sorry, we're gonna pretend it does. Show me the formation between calcium and phosphorus. Ionic compound, calcium and phosphorus. The reason I'm doing this, we'll still name them like it's an ionic. So some of our polar covalent really fall in the naming system. The next chapter, the first thing we're gonna do is binary ionic compounds and their nomenclature. And calcium phosphide would fall into that. Does anyone want to come to the board and do it? Bittner? Everyone see it? She's doing it backwards, but that's okay. Typically, we're gonna arrange you, we're gonna go positive first, and then negative, it's okay. You don't like that. There's really no set order, but from here, once we start naming them, it's always the positive first, then the negative. You don't have to show the arrows, that would be a nightmare. You could do it, but it'll muddy it all up if you show all those arrows. Thank you. Everyone see that? It's wonderful. please tell me, we can look at the periodic table and we can do this. 0, minus 1,
Minus 2, minus 3, plus or minus 4, plus 3,
plus 2, plus 1. So as long as you can do that, you know what charges are gonna form. That calcium is gonna be a +2, the phosphorus is gonna be a -3, you cross those charges. There is the formula for calcium phosphide. We'll start naming these in the next chapter. When you show the formation, it's busy work in this chapter. You're actually showing that all those valence electrons are by calcium are given away, making it +2. It gave away this one and this one, it's a +2 charge now. We show this calcium with no electrons in its outer shell, though you all know that it really has an 8 in its outer shell, because its inner shell became its outer shell. It's very satisfied, very happy with its octet. It has become like argon, with 18 electrons now. This phosphorus has gained 3, becoming like argon. It now has 18, and this it has 18. That's showing the formation of an ionic bond. I think that's the hardest thing on the test, to be honest.
Wouldn't there still be a calcium with 2 dots on? Cause like, doesn't each phosphorus or whatever,
Each calcium now has 0 dots.
but doesn't each of these only need 2? That would be
No, they need 3, because there's only 5 in the outer shell.
Yeah. 8, 7, 6, 5. As a result, 0, -1, -2, -3. Yeah, I have people with this mistake, they'll start here with -1 on the right column. Don't do that. That's 0, then -1, -2, -3. Okay,
Can you give us another one?
yeah. Let's do. Let's do aluminum bromide. Aluminum and bromine. I told you I don't like busy work. This is the one thing I think I was assigned it as busy work. Good news is it goes away. It goes away. Everyone see why it takes 3? Is it raining?
Yeah. There's thunder, like, when you're in class.
Yeah, it's the weather.
Yeah, what am I doing on my hair? Going to my next period class, no, it'll be fine. I'll just dry it. Done.
You should
Everyone see
probably be more concerned about your beard.
Yeah, beard.
Yeah.
Are we ready to start? start the new material? Here's the new material, let me show you, just a little bit.
No, can you give us one more Lewis structure, please?
We're gonna do Lewis, these aren't Lewis structures.
Yeah.
We're gonna do Lewis structures. But while we're talking this, watch this. When I start giving notes for the next chapter, here's how I start. This group here forms no ions. This group here does a -1, -2, -3, plus or minus 3, plus or minus 4, plus 3, plus 2, plus 1. I screwed that up, I didn't think it was possible. So, we're gonna start bonding stuff together in ionic bonds. Essentially metals bonded to non-metals, and we're gonna name them, it's called binary ionic compounds that are nomenclature. That's a scary word, nomenclature, it's naming them. You biology people talk about nomenclature, naming things. So, watch this, if we just have potassium bonded to oxygen, let's get the correct formula and name it. Well, what are we gonna do? Watch this. Anything with a minus charge, we change the name. We call it I. So instead of fluorine, it is, you guys know this on your teeth, fluoride. Chlorine is chloride. Bromine, bromide. Iodide, iodide. Oxygen, oxide. Sulfur, sulfide. Nitrogen, nitride. Phosphorus, phosphide. And carbon, carbide. Now, why don't I have a bunch more to learn? That's it. Those are the only nonmetals. What about these nonmetals? They don't bond. Okay? So essentially, we're going to take the whole rest of the periodic table and bond it to those few nonmetals and name them. Look, watch this. The charge on this wants to be a plus 1, Na minus 2. We bring the 2 down here. We don't bring the 1. We name it potassium oxide. People say, well, shouldn't we name it dipotassium monoxide? We don't need to. What's the charge on potassium all the time? Plus 1. What's the charge on oxygen all the time? Minus 1. That's it. Aluminum and oxygen. What's the charge? Charge. Aluminum oxide. Folks, it's gonna be so easy. Where we're heading this next stuff in chapter 7, we're gonna be cruising. What are we doing? We're actually doing this. That's a lot of work right there. So I apologize for that now. Why do we even do that? Because it truly shows what happens. We have an empty spot on each one of these bromines, and it gets filled by one of those, and one of those. That's it. That is the formation of an ionic bond. Then they're bonded together. Are they sharing electrons? No, they've exchanged them. Why are they bonded together? Static charge. Opposites attract. So positive charge and negative charge attract those things, hold those together. So, man, that's gonna be good stuff. Good stuff. We'll start developing the language and name some compounds. Throw some polyatomic ions in there. We're rocking and rolling. Speaking of polyatomic ions, that leads us to Lewis structures. Let's do some Lewis structures. I will never ask you the 6 steps in writing a Lewis structure. You're going to show them. Okay? So, Lewis structures involve elements that are exchanging electrons or sharing electrons. They're sharing electrons. You understand this? So the formation of these ionic bonds, they were giving electrons away or stealing electrons. Now we share. Okay? So let's do, you know what, I haven't even done this. I don't know if I've ever done this before. Let's look at, do I want to do that? Or is that going to mess us up? Yeah, let's not do that one. Let's go with. C, carbon difluoride diiodide. We'll do the one I thought of. When you're done with that one. Do carbon monoxide. Anyone heard of carbon monoxide? Who's putting the first one on the board?
Wait, can you see if I did it right first?
No. Thank you for being a brave soul. If you make a mistake, it'll honestly help everybody out.
I'm gonna do it right.
How many fluorines?
Oh, that makes sense. That's why I did this wrong.
You have a second one? Just wait.
Does it matter if I put it?
Doesn't matter. She had put one fluorine and one iodine, and it had all these double bonds, and it worked. Make sure when you go back, make sure you have the correct number of atoms. Okay? Just make everyone happy. Yeah, you're doing right.
Okay.
Remember, step 4, you do your skeleton structure, and you just make everyone happy. Be the bad parent. Just give them what they want. Give them what they want. Give every element exactly how many they want, and then count.
Wait,
You're thinking too hard. Just go around, give dots to everything to make it happy. Do you get, no, but it wants 8 in its outer shell. Bingo. It goes through hydrogen nitrogens, do you do that? No. That's 32, yep, thank you. We're doing carbon monoxide now.
No, I did it.
Never see his zeros, he rates his zeros up, I did that for a lot of time, for a long time. I was a teacher, I bet I was teaching 5 or 10 years, and the kids started laughing at my zeros. I would draw zeros starting at the bottom, instead of starting at the top. So they told me I was wrong, so I've made the switch. Anyone see it? Perfect. Watch this. When you put carbon and oxygen together and make everyone happy, you mistakenly added too many. You only have 10 electrons available to share. So we have to go through erase 2 and erase 2, make a double bond. Now we're down to 12. Erase 2 and erase 2, make a triple bond. There's carbon monoxide. Everyone see it? Let's do a polyatomic ion, do you agree?
Yeah.
So let's go. I don't know if I've ever done this before, we're gonna do it, it's polyatomic ion, we're gonna do it.
Let's do it.
NO2 with a -1 charge, you'll know that in a couple weeks to be nitrite instead of nitrate. We did NO3, right, it had a double bond. Remember the NO3, we did NO3 -1 charge, here's NO2 -1 charge. Oh, this is boring, that's gonna be easy, I can see it now. The nitrate's a lot more exciting, we had to double bond it, this is really boring. Yeah, is it? I don't know. It might not be. If I can do it. I've never given this. It's gonna be tougher than I thought, but it's okay.
Wait, why do you have 3 oxygens?
What?
Why do you have 3 oxygens?
Oh. That helps.
Every time it's like, oh no, I think it's
That's one NO3.
like it looks like you know.
Maybe it's really easy.
I'm sorry.
Oh, it's 20. You have 20?
No.
When you put it on, you gotta go to 18?
Yeah.
That's really easy, sorry.
Wait, no, I had to
No.
have a double bond.
Yeah, I did a double bond.
Yeah, you're gonna have to.
Oh, okay.
But it's only one. I was at 26.
Oh,
I was at 26 trying to get down to 18. I'm like, oh my gosh, it's not gonna work. It has 3 oxygen. It's gonna be okay. Nitrogen. 1 times 5 is 5. Oxygen. 2 times 6, 12. We're at 17. Plus 1 is 18. Let's make symmetrical. We should draw a little structure for each one. I'm not gonna check that. I'm gonna check, did you get this right? And then you have your Lewis Church is drawn correctly. We make it symmetrical, here we are, an oxygen, make them happy. You're gonna be Santa Claus right here. You give every kid exactly what they want, electrons in your outer shell, and then you walk away and let someone else deal with it. Let the mom, I'm gonna be a mall Santa Claus probably, aren't I, before, when they look at me, it's inevitable, so I'm gonna be a Santa Claus, I need to learn to do that. I need to learn to smile and be nice to kids, I know I can do that.
Wait,
Think about this,
show us your smile.
I agreed to cover, there's a bunch of freshmen I've gotta watch ninth period today, I'm afraid I'm gonna lose it. Say a prayer for me,
Okay.
Mr. Weber, grant Mr. Weber patience.
Godspeed, Mr.
Freshman ninth period to end my day. We're at 20. You agree?
Yeah.
2, 4, 6, 8, 2, 4, 6, 8, 2, 4, 6, 8. A total of 2, 4, 6, 8, 10, 12, 14, 16, 18. We put brackets around it and we show that it's a -1 charge. That's it. There's nitrite. Do you want to do oxalate?
Yeah.
Sure.
Why not? Sure.
Never done oxalate before. This could be crazy. C2O4 with a -2 charge.
Oh wait, okay, yeah, never mind, I did that one.
C2O4 with a -2 charge. One of our polyatomic ions that we're gonna learn here next week is called oxalate. Real quick, I just wanna show you something here. After we do the binary ionic compound, remember we did like aluminum chloride? Remember this, doesn't aluminum chloride always look like this?
What's 24 plus 8?
Doesn't aluminum fluoride look like this? What's aluminum iodide look like? What's aluminum bromide look like? Because it's a +3 and a -1. Watch this. What if aluminum were to bond with nitrite? Well, guess what? It's aluminum. Now we put parentheses. The -1 goes down here, the +3 goes down there. There's aluminum nitrite. Anyone seen that?
Why do you put in parentheses? 'Cause it's two
Because it's a
different
polyatomic. We need to take the entire thing 3 times.
compounds. Oh, okay.
It's an ion of atoms bonded together.
What happened to the -1?
That's where we're heading. If that confused you, don't worry, it's not now. What did I say, oxalate? I just said oxalate, didn't I? Oh my gosh, let's see. Oh, I'm scared of. Doesn't matter.
Wait, what if we did all the oxygens and then the 2 carbons on the end?
Should work.
Okay.
Usually carbons are central to an atom or to a molecule. So it doesn't matter. I might pick this one down here. Oh, it's a -2, right? 38. Everyone agree we need some double bonds?
Yep.
I'm just gonna go there. And there. 2, 4, 6, 8 around this one, 2, 4, 6, 8 around that one, 2, 4, 6, 8 around that one, 2, 4, 6, 8 around that one, 2, 4, 6, 8, 2, 4, 6, 8. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26, 28, 30, 32, 34. Anyone see it?
Can you show it the other way?
No. Because this isn't right. But we don't do the other way.
The rectangle, we like to do the rectangle.
You had two ways to make it. Like,
Oh, I see. You're saying this one.
yeah.
I thought you were talking just using their dot symbols
Yeah.
and put them together.
What did you mean?
He thought that she was talking about like, when they just take the electrons. Not
Yeah.
Raise 2 from here and 2 from there, double bond. Raise 2 from here, 2 from here, double bond. 2, 4, 6, 8. Mistakes I'll get by some people is I see 5 lines attached to something. 2, 4, 6, 8, 2, 4, 6, 8, 2, 4, 6, 8, 2, 4, 6, 8, 2, 4, 6, 8. 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26, 28, 30, 32, 34. Shows a polyatomic. I put in parentheses around it. Folks, that's it. Am I right? That's oh, we forgot the granddaddy law. We need to have a discussion on why some things are liquid, some things are gases, some things are solids.
I thought we already did that.
We did, we spent a lot of time on that the other day. So, but you understand, that's what it'll be. I'll tell you what they are. You know what I mean, I'll tell you, this is a liquid, this is a gas. Why would that be? Make sure you can show that water's a dipole and hydrogen bonding
Can you give us like an example of like one of those?
of hydrogen bonding,
Yeah.
or why one thing's a liquid, one thing's a gas.
Both.
Okay? Here it is. Water at 18 grams per mole and is lighter than air. Let's go nitrogen gas at 28 grams per mole. This is a gas at room temperature. This is a liquid at room temperature. And do something like, yeah, let's do this. Lithium fluoride, what do we got, 7? And fluorine is 19. At 26 grams per mole is a solid. Okay? So you look, well, has nothing to do with weight, does it? Doesn't matter. Here it is. The heaviest one's a gas, the lightest one's a liquid, and the medium one's a solid. Why? That will be a discussion. I would expect you to be able to maybe draw Lewis structures and have an explanation as to why one's a gas, one's a liquid, one's a solid.
Wait, is this like what it's actually done on testing and give us
Yeah.
these? Oh,
Yeah.
okay.
Yeah, I would give you those and tell you which one's a gas, which one's liquid, which one's solid. You're gonna tell me why it's a solid, why it's a liquid, why it's a gas.
Are ionic bonds always a solid?
Yes. Ion bonds are solid. Why?
Always.
It's a completely positive and a completely negative.
So you could just say that like.
That's a +1, that's a -1.
Yeah,
When
like
another one comes along, it's gonna be attracted the lithium plus one's gonna be attracted to there. So it would be fluorine and lithium, attracted all the way around, just locked together.
So like we could answer like that part of it,
Yeah,
and just say
yeah,
iron
Okay? Here, you better draw Lewis structures on those. Draw Lewis structures. Please tell me. There's nitrogen. Is there a positive end or a negative end to that molecule? No, there is not. As a result, it will not attract to other molecules. They'll just bounce apart. That's why when the window gets opened on the spaceship, you suffocate, you die. Yeah, the air is gone. Because they're not attracted to one another. Please tell me hydrogen bond, we can draw that without even doing a Lewis structure. It's bent, partially negative end, partially positive end. The water's lighter than air, it clings to other water molecules at room temperature,
So,
and we have liquid water. Hallelujah.
So we can just say, like, if it's even, then it's always a gas, and if it's not, then it's.
Right
Not
now,
always.
now, you introduce, when you say always, you introduce an interesting topic.
Almost always.
When we cool that down now,
Like, in
do
this
you remember the London dispersion force? Why is there London dispersion forces? Well, apparently there's an instantaneous polarity develops in this nitrogen that if we've cooled it down enough and if the particles are moving slow enough, that very weak attraction can hold them together.
We can just say like, since it's a polar molecule, it would be liquid, like.
Yeah, a polar molecule is gonna have a hydrogen bond. Is this a hydrogen bond? No, it is not. What's a hydrogen bond? Is an intermolecular bond. That's the hydrogen bond. That's what makes that a liquid, yeah.
So we should just not say always, just don't say always.
Yeah, well, you're gonna have to, you illustrate why this one bonds together, and it's then a liquid.
Oh my god. Sorry. Sorry.
And I don't wanna confuse this, but you understand this bond isn't locked in place, it's an attraction. It's attractive, but it's gonna float by, it's gonna be like a mingling through a crowd. Okay? So there's an attraction there, but it's not locked in place. Whereas in a solid, those particles are locked in place, just like you guys. You've been sitting in the same seat the whole time. You're locked in a particular spot. Imagine you're a junior high class and you're up milling around, a little bit higher energy, and you're not sitting in the same seat. Oh gosh, I gotta go to those freshmen. That's how my wife does her job. Kindergartners every day, all day long.
I feel like.
She has hair. I have no hair. I have no reason for having no hair. I have you guys. You guys are good to me. You know what? If I yell at those freshmen, they'll never take my chemistry class because they'll be terrified of me.
Well, they're never gonna think.
I won't even be here. Maybe I
You
should
should still
yell.
yell at them anyways. Wait, what
Yeah, just
class
yell
are
at them.
you-
Yeah,
What class is
class
it?
is
Oh,
Spanish.
Oh,
Spanish one. Are they good?
no.
They're bad, they're really bad.
Can you yell at them in Spanish?
Yeah.
I don't understand.
¿Por qué? ¿Por qué?
I can yell at them in French. I don't know how to yell at them in French. It's been 30 years.
Just yell at them in
35
French
years.
and tell them in
Search it.
Spanish.
Search it up.
Yeah.
Should have Franco in there.
Nope, not to yell at them. They're gonna be.
That's your goal. What if they do start like making us more, go just like,
¿Por qué? ¿Por qué? ¿Por qué?
that's what they're yelling because, that would be a lot.
Because.
Other poor kids
Oh,
because.
Because
Well, there's two different poor kids.
What is-
Yes, question is why.
I'm gonna just stick with English. Have a nice weekend. Test on Monday. We'll be rocking and rolling.
Might just crack.
Godspeed.
We should have.
Down where?
2
One? Okay, so I wanna rewrite this so I can know it.
plus 1, and get smaller.
I'm going to help with the blood drive.
Okay.
Wait, why does it get smaller?
Because it got rid of its outer shell.
Oh, okay, so
An
two.
electron, a plus 1, it's getting rid of an electron.
Yeah, I'll just put you there.
Plus
Plus
2,
two,
smaller. Plus 3, smaller.
Look,
And look, I marked that wrong because you have plus or minus.
Hey, what? I look so far again. Are you gonna?
Minus 2, larger, minus 1, larger.
because it's minusing.
Because it's gaining.
Well, minus is gaining, because it's a net electron negative.
Yes, it's gaining
So
electrons.
say 17 is minus 4.
Yes.
And then